Okay. Okay. So today we're going to do 2 more types of fixes, and then another long voyage across California. And then the final assessment or worksheet you guys should have already. And I recorded earlier today a step-by-step tutorial doing that. So I don't want to like completely ignore it, but you guys can feel free to watch the video as many times as you need. It's going to be on the YouTube channel. And then next week, I'll answer any questions on that if you have any, and then we'll go straight into some set and drift of what we usually cover in CoNav 2.
Cool.
So that is the plan. Then we're going to take, as for me, we take July off, or June off, and then in July we'll have Celestial, which you guys are more than welcome to take. You don't need CoNav 2 for that class. And then I will also do some kind of weekend tutorial. So if you want more tutorial on these kind of topics, that's what the weekend tutorials are for. Just practicing whatever you guys want to practice or give a little more attention to. So, so that's my schedule. And I don't know if OCC is having more classes being taught, but let's get started. Okay, so let's bring up the PowerPoint here. All right, can you see the PowerPoint?
Yeah.
Yes.
Okay.
Yes.
So
By the way, did you get a chance to send this out or not yet?
I did on Sunday.
Oh, okay.
Did anybody else get it? Did it not go through?
Yeah, I've got it.
Okay. Yeah, I sent it out on Sunday.
Yeah, okay.
Okay, so the first fix we're gonna do is called the bow and beam fix. Now this fix is kind of this quick and easy, not necessarily too accurate, but a quick and easy fix. So the idea behind it is this isosceles right triangle. So back to geometry days of many moons ago, an isosceles right triangle means you have a 90-degree angle and then 2 45-degree angles. So if those 2 angles are exactly the same, that means the length of these 2 sides of the triangle are exactly the same. So that's what an isosceles right triangle is. Now, if we put that concept into plotting, we could say if A is a lighthouse, right? We have a little lighthouse there. B is when we see the lighthouse broad to starboard. So that means a 45-degree off the bow. So can everyone kind of visualize where you would see that? You know, right, not quite on the beam, not on the bow, but somewhere in the middle, right there, is your 45 degrees bow sighting. And then you note the time in your head. And then when you are abeam of it exactly, the distance you traveled from point B to point C is the same distance you are away from the object in question. So if we use distance run, that will equal distance off. Those are the 2 terms they like to use. Distance run is equal to distance off. So using our 60D street to calculate if we were here at a certain time and there at a certain time, we can calculate the distance traveled, distance run, and then that would equal distance off, and we could plot that position with 2 LOPs. So we're going to go through the steps and then do an example and then do an example together. Any big questions so far? Okay.
So
yes,
you get a bearing and a distance off out of this one thing.
you get a heading. So you are assuming, you're assuming heading and speed, just like a DR.
Uh-huh.
You're assuming that you are maintaining the same heading and maintaining the same speed throughout this whole process.
Okay.
So the two things that you do are note the time when the object is brought on the bow. So that's 45 degrees to starboard or 45 degrees to port, which would be 315 relative. And then note later when it is exactly a beam. So you're just noting the 2 times. If you have a tool, it would be more accurate. But again, this is just kind of this quick and dirty kind of simple type of fix. You could use your 60D street to calculate the distance run equal the distance off, and then you plot your LOPs. So, okay, pro tip, use the structure on your boat to get these bearings. So something that's perpendicular to the center line to get you that beam bearing, maybe the end of the cabin or the forward end of the cockpit, pair of winches lined up. You can use different things with the structure of the boat, depending on what kind of boat you're on, to help you get that bow or beam fix, or bow and beam line. So let's do an example here. Our example is we're on course 000, we're headed north at a speed of 10 knots. We see the lighthouse on the bow at 0600, and then we see the lighthouse on the beam at 630. So we're here at 600 and we see it 45 degrees on our bow. And then at 630, we see it directly on our beam. We calculate the difference using 60D street, 30 minutes. Our speed is 10. So we have a speed of 10, a time of 30 minutes, plug it into 60D street, and we get our distance off of 5 miles. So then when we plot the first, when you plot your LOP, you plot it 90 degrees to your track line. So if you already have your track line plotted, it's a simple draw 90 degrees from it. If you don't have your heading already plotted, then you have to do that R plus S equals T. That is relative heading or relative bearing plus your ship's heading equals the true bearing. R plus S equals T. So that gives us a bearing of 090.
So Bree, you are assuming that there's no current, right?
Correct.
Okay, thank you.
So we're assuming speed and heading are what we think it is. Mm-hmm. So when we plot it on the chart, we plot that 090 line, and then we plot our distance. So we have a line, and then we have a distance of 5 nautical miles. So we plot that distance of 5 nautical miles using those 2 pieces of information, and we could say right there is our 630 position. Any questions on that?
So where's that in the hierarchy of credibility when you're?
Just above DR. So you have a DR, which is just course and speed, and then you have this one.
Okay.
So it does give you a little bit more, but it's all dependent on the accuracy, on how accurate you can say, 6 o'clock it was brought on the bow. Maybe it was 6:02. Maybe it was 5:58. You know, somewhere around there, you're going to mark the time.
So it's in between a dead reckoning and a line of position fix.
Yes. Yes. So, yeah, it's all about the accuracy of that. Okay. So let's do one together on the chart. So this is assignment 13. So we can do it together here. So assignment 13 has our practice bow and beam problems, and then our practice running fix. Okay, let me mark Luca, you get that here. Okay, so it tells us at 12 o'clock, you plot your position at 33 degrees north, 30 minutes, 118 degrees, 26.1 west. You're traveling on course of 115 degrees true at 7.2 knots. So let's just plot that information there. So I am going to grab my divider over here. Okay, so this bold line is our latitude line, right? It is 33 degrees 30 north. So I know I'm somewhere along this line. To get my longitude, I'm going to get 26. So here's 25, 26.1. So I can say I am going to be here at 12 o'clock. With me so far?
Yep.
Yep.
Okay. Then it also told me we have a course of 115. So I'm going to get my course. So we have a course of 115 degrees true at a speed of 7.2 knots. Okay, and then it asks us for number 1, using 60 D Street, how far did we travel from 1216? 1216, we had long point on our bow. And then at 1248, we had long point on the beam. So using 60 D Street, how far did you travel? We need to know our difference between these two times. So we have 1248 minus 1216. 2, 3. So we have 32 minutes. Guys, I am using the wrong time here. No one caught me. 1248. No.
46.
That's 12:46.
Man, I did that twice. 1246.
It's 30 minutes.
Yes. I was like, why am I getting 32 minutes? Okay. 46. Okay, that's an easy 30 minutes. Okay, so then we have our time is 30. Our speed is 7.2. What is our distance?
It'd be 3.6.
So we have D equals S times T divided by 60. 7.2 times 30 divided by 60. And what did you get for distance?
I would think it would be 3.2, 3.6.
3.6.
It's half of 7.2.
Yep. That's it. That's it. Okay, so we have our distance of 3.6. And our distance traveled is equal to the distance off. So when we plot this, we can first plot our 90 degrees, our beam bearing, and this is from long point. So using the triangle, you can either do something like that, right? This is on our course line. So you're just making a perpendicular line to our course line that goes on long point. I like to use the black line. That's just my preference. I'm just putting this black line on it, same concept. So I am somewhere along that line. And then I'm gonna get on my dividers, my compass here, 3.6. From long point, 3.6, just about on our track line. And that would be our 1246 position. Now we can, go in and draw the other LOPs and kind of prove it, but we don't really need to. Was there any questions about that?
Ray, just on the 46. Shall we draw a circle or half circle?
You can draw a full circle.
Okay.
Well, it looks like on this triangle, you could just measure it from it looks like that lines up to the latitude lines on the side of the chart. So it looks like you could just use that to measure that.
Mm-hmm.
Yeah.
So yeah, the next question, number 3, is what is your position? So everybody does their position a little differently. I like to do mine like that. So we are just past this line, barely. 20, I'll call it 20.2. And lift up my computer here. And then I got 25, 26, 27, 27.2. No, 7, 27.7. 27.2. Oh, I had it right. Okay. We're going to move on to running fixes. They're a little bit more tricky. Any big questions on the bow and beam?
Nope.
Okay. Share. Okay, so for the running fix, this is another big one that you might use a lot. The difference between a regular fix and a running fix is that your line of positions are at different times. So ideally, on your regular fixes that we've been practicing, you're getting these bearings simultaneously, all at the exact same time. But if you happen to get them at different times, whether it be a half hour later, 5 minutes later, 2 hours later, however it is, at different times, you can still use that old information and the new information to create a running fix. So it's 2 or more lines of positions that are obtained at different times. You advance the earlier LOPs to the time of the second observation or the latest observation using your known or assumed speed and direction. So that's the official definition. And these are our steps. And then we're going to go through it, of course, but I'm just going to read out the steps here. We have a DR track line plotted. So that means we had a known position, and then we have our course and speed. Our first step is to draw in the first LOP at whatever time it was. And then using 60D Street, we can calculate the distance traveled from the time of the first LOP to the time of the second LOP. Then we're going to parallel that first LOP to the time of the second LOP, the distance traveled, whatever that was. And then where that LOP is, that's your advanced line. Wherever that cross plot your second LOP, wherever those two intersect is your running fix. Now, when we draw this, did I make this animated? Nope, I didn't. Okay. When we draw this, we will end up getting a lot of triangles, but we have to remember that our track line, our DR track line, is not an LOP. It's just where the 2 LOPs, we have one at the current time and one that we've advanced. Wherever those 2 meet, that's our running fix. It doesn't matter where the track line actually is. So that's one we're going to remember. Okay, so these are images better than I could draw or animate. And I'm going to explain them here. So we have, this is our track line. We have a course of 012 at a speed of 12 knots. And we have a DR at 1500. And we have a DR at 1520. So that's our basic track line. At 1500, we got a bearing to light E. So this line is at 1500. So I can be anywhere across this line, meaning I'm not right on my DR, right? My DR is right here. So I'm probably moving faster than what my 12 knots is. But I could be anywhere along here at 1500. Now, in order to advance this to 1520, I use the distance that I would have traveled. So if I do my 60D Street, I get a distance traveled of 4 nautical miles. So you put your 4 nautical miles starting from where they intersect your track line, advance it, and then draw in your line again. So this is just how we label and how we would draw an advanced line of position. So the term is either advance or retard the line of position, moving it along your track line. The only reason you would retard a track line is if you wanted like a noon fix or a 1500 fix and you got it at like 1505. You might move it back to 1500 to get a running fix that way. Okay, so this is an image of an actual running fix. That was just one advanced line. So here, can you guys see my mouse when I'm moving it?
Yeah.
Okay. Here we have our 1440, And this is our track line. So we think we're going to be here at 1500. We think we're going to be here at 1520. We're doing the same 12 knots. So we plot our LOP 1500. Then we had our advance 1500 to 1520, right? We advanced it the 4 miles that we would have traveled. And at 1520, we get a fix off of stack F. So that LOP actually happened at 1520. This LOP actually happened at 1500, but we advanced it 4 miles. So this would be our new fix. Then we plot our track line again to get a better DR that says, hey, we are getting closer and closer to shore. We should probably do something. Okay, so in this image of the running fix, we got our 2 LOPs off of 2 different lights. We had light E and stack F. So that is kind of like how we've been getting our positions, right? If we had E buried here and F buried here, we're right in the middle. The other cool thing about a running fix is you don't need more than one aid to navigation, more than one point of land. You can do it off of the same thing, just at different times, and it still gives you a position. So this example, here's our basic course line. We have our 018, 12 knots. This is where we're headed. At 1430, we see light G. And then at 1452, we see light G bearing over here. So in order to advance 1430, we advance it, 22 minutes. However, we traveled in 22 minutes, whatever this distance is. Draw in the line again. And then from the same light, we got a bearing. So now we have a new running fix. I'm hoping this will make a lot more sense when we do it on the chart.
So the last statement, I didn't quite understand the logic of last statement. Yeah, I understand you have that the advance for distance that you can calculate that. Mm-hmm. What's the point? What's the logic for that R fix at the 1452?
Is that we only had one thing to take a bearing from. So at this time, we know we're somewhere along this line. We don't know where. And then at this time, we know we're somewhere along this line, but we don't know where. So in order to get a better idea, we meet those 2 lines together by advancing this LOP to the time of the second LOP. So we parallel this line all the way up to where it would have been 22 minutes later. So then we can have a more accurate. So if we go on our scale, right, we have DR, and then we have that bow and beam, and then we're going to have this running fix.
Okay, it's hard to comprehend. So I'm not quite sure what's the physical meaning of that, because it's the middle of the ocean, right? There's no mark for that point.
You're on the coast, so this is the coast. You're in the water here, and this is land. Yeah,
I can see the light will be a physical mark if everyone can see, but the new ones you draw on the R fix, that's no reference, right? There's nothing you can spot on. So what's the practical use for this? Yeah.
It's just a more accurate than the DR.
Okay.
So we had the DR, and then if we were just to use one line of position, that would give us what's called an estimated position. And so wherever we are closest to our DR on that line, so technically our closest spot to the DR would be about here. And that would tell us we are to the left of track. Where in reality, we're way over here. And we know that because 22 minutes ago, we got another bearing. So we're using that old information to give us a better fix now. And that's a running fix. Okay.
Okay, I'll try to think about it.
Let's see, maybe this one's a little bit harder to conceptualize, but sometimes it works for people.
Yeah.
Okay, so let's see, we are here on course. Am I on the right thing? Course 076 at 15 knots. Here's our DR for 1440. Here's our DR for 1508. So at 1440, I get a distance from this buoy. So my distance is whatever this is. It doesn't tell me what it is exactly. I get a distance. I'm somewhere along this line at 1440. And then I get a bearing off of this light at 1508. So I want to advance my arc. And how I advance my arc is moving that aid to navigation with me. So I move it along as if it just traveled my same course and distance until you get to however far you would have traveled. And then you swing the arc again. So you're just advancing this arc to this time. And then you get a bearing from light H. And wherever that crosses your advanced line of position, you get your running fix. So essentially we're kind of creating this, like, if it was an arc and it was a straight line, we'd be creating this kind of like parallelogram. When I get on the chart, I will draw it out on the whiteboard. That might make better sense. Okay. Okay, let me draw it out on the whiteboard. Stop share. Okay. Okay, so here's the California coast. This is land. And we have a light right there. We have a fix at 12 o'clock. There's my course line. So let's say at 12:20, I get a bearing to that light. So let's say my DR was actually right there. So in order to do an estimated position, the rule for an estimated position is wherever this line is closest to that DR line. So we're going to call this 12:20. Okay, so how do you get closest to the point is our famous perpendicular line. So we could line up. To say the closest spot on this 12:20 LOP to my DR is right here. So if I know I'm an infinite possibilities on this line, right? That's what an LOP is. infinite possibilities on this LOP, and I had a DR just using my course and speed, was right there, the closest point to that would be my estimated position. That's what they call an EP, an estimated position. If you want to do it like that, your EP is a square. Okay, so then we'll say a half hour later, use a different color here. Half hour later, we get another LOP from the same light. Oh, I don't want to do it quite like that. Let's do it like that. Okay, so we'll say this one was at 1240. We want to parallel, so we want to move this 1220 line down to 1240. So we have to calculate the distance we would have traveled. I don't know what the distance we would have traveled because I didn't put a speed. Something like that. Maybe you'd go past that line. Doesn't really matter. So then we would parallel this line. We'll use the parallel. I don't think it'll work on the whiteboard. Parallel it to where it intersects that line. So these are parallel lines. And now I have this LOP to equal 1220 to 1240. So now I have two LOPs at 1240, and that means I can get a position to say that this is my R fix. It's using two LOPs at different times, but I advanced this one to the 1240, so I can call this my 1240 R fix. Did that help clarify anything? Okay, let's try our example. It's over in Dana Point, so I have to move my camera. Hold on. Okay, at 8 o'clock, we have a position. Still don't think you can see where we are here. Okay. Okay, so at 8 o'clock, we have a position of 1330. So we're on this line. And then we have a longitude of 1750. So we are on that line. So we have an easy position of 0800. We have a course of 143. excuse me, with a course of 143 at a speed of 10 knots. The fog rolls in and we have patchy visibility. So we are able to see this buoy. So we're looking at the buoy right off of Dana Point Harbor. That guy. At 8:25, let me get my whiteboard out. Okay, so we have two bearings. Let's see. So we are here at 8 o'clock. At 8:25, this light was bearing 080, and at 8:43, it was bearing 3030. So I'm going to plot those LOPs. So I had 080. So I'm somewhere along here at 0825. And I am somewhere, this one, 030. All right, I'm going to pause for a minute, let you guys catch up a little bit. Okay, so I have my two LOPs. And now I need to advance my LOP at 8:20. One second. Okay. Okay, so I have the two LOPs. And now I need to advance this 8:25 LOP 18 minutes down our track line to 18:43. So I need to see how far I would have traveled. So in 18 minutes, do the old magic circle. Speed was 10, time is 18, distance is question mark. We have 10 times 18 divided by 60, 3 nautical miles. So I'm gonna get 3 nautical miles. Okay, so this is where I'm doing my 3 nautical miles from. From where this LOP intersects with this course line, track line. And I'm putting a little mark. So this distance was my 3, put it over here, my 3 nautical miles. So now I need to parallel that line. Use the parallel to make it a little easier here. All the way down to that point that I just drew. Okay. So I can call this line 0825 to 0843. And I get this triangle here. But remember, the track line is not an LOP. So this right here would be my 843 R fix. Any questions on that? Were you guys able to do it on your chart?
So, are you assuming that the speed is constant, right?
Yes, we are assuming our course and speed.
Okay. So I think, you know, if that's the case, why don't you use 40, let's say, 43 minutes travel distance and draw a circle from the where the 8 o'clock you were. That was the original location. So you have, so you have a circle, right? Or you have a curved line, okay? So whenever the curved line meet the either from there or from the 8 o'clock position, right? So then you will meet this line of the second line, which is
Because we are anywhere on this line.
right.
So if you draw the curve from here, it's going to be a lot different than if you drew the curve from over here.
No, what I'm saying, you draw a curve, use the center as where the 8 o'clock position was. Yeah, use that one, right?
To do what?
Yeah, to say you can calculate 43 minutes altogether how long you travel, right?
Yes.
So use that as a, you know, and then draw a circle, and if that intersect with that
Oh, I see what he's saying.
with that
Okay, so you're saying for the 43 minutes, how far would we have traveled?
Mm-hmm. And then strike an arc for that 43 minutes of distance.
Right.
So I get,
But actually, that will be a different answer than what you did.
Yeah, well,
so we would have traveled 7.16 for 8:43. So let's get that in. 7. Okay, so from 8 o'clock,
Yeah.
if we traveled 10 knots, we would
Right.
be somewhere along here.
Right.
So if we look at this, this is our 0848 DR, 843. So with this line of position at 843
Yeah.
and this DR, I would say using those two pieces of information, if I'm in infinite places on this line, and this is my DR, wherever this DR is closest to this line. So again, I do something like that. So I would call this my estimated position. Zoom in on this a little bit more. Can you guys see that? A little bit?
yeah.
Okay, so this is my track line. This is my 843 DR, this curve.
Right.
So if I assume my course and assume my speed, then this is where I think I am. But I got this LOP, so I would say this is my estimated position because it's one LOP and a DR. So wherever my DR is closest to the LOP, that's my estimated position. But I'm going to go further and advance the old LOP. And that's how I get the running fix. Now, you're saying we could be anywhere along this line. Yes, but we are assuming course just like we are assuming speed. So in order to take into account that our course and our speed might not be exactly what we think it is, we're going to use our old LOP. I feel like I'm still not answering your question.
What do you think the intercept between the curve and the LOP at 430? Yeah, right there. What is that point?
I wouldn't call that a DR either. I guess that would be your DR if you had no idea what you were heading. But you're assuming you're heading just like you're assuming your speed. So this would be your DR if we had no idea what our heading was. Because it's just using, or it would be your estimated position, just using speed and one LOP.
Yeah.
So, you know, we're an infinite possibilities on this line, right? And now we have 3 possibilities. We have this estimated position using our course and speed. We have this estimated position only using speed, no course. And we have this running fix using an old LOP. So I guess in reality, we could say we're somewhere in this region, if that's what mattered. But
other than that intercept, the other 2 points,
This one and this one?
yeah, those two are not assuming the constant speed, right? There are some variation of speed.
They're assuming constant speed and direction. Because I advanced this line 3 nautical miles, assuming that I would be traveling 10 knots. And in 18 minutes, I would travel 3 nautical miles. So I'm assuming that 10 knots by advancing this LOP.
Okay. All right. I'll think about it. But I'll so far right now, I'm thinking if you assume the constant speed, then the position has to be on that curve. Otherwise, it's not a constant speed. But I could be wrong. I will think about it.
Okay. Okay. I'm going to erase this. Let's take a 10-minute break here. What time is it?
7:30.
At 7:30. Let's come back at 7:10-ish, or 7:10, 7:40, and we will start on assignment 14. So we have the advanced cruise along the California coast.
All right.
Yeah. So let's take a breather, and then we'll get back. Are you guys back?
Yeah.
Yep.
Okay. Fred, I wanted to go over this one more time.
Okay.
I
Thank
erased mine because we're going to be plotting over it.
Uh-huh.
But one thing that I want to remind you of is we always use the latest information. So we were here at 1800, and then we had swung that arc, right, for if we traveled 48 minutes. But we did get this 825 line, so I don't want to completely ignore that. Now,
Okay.
if I plot my DR, I'm slightly past that line for my 0825 DR. So I would say my EP is right about there. So if I shift my arc just a teeny bit back, it does get us closer to the running fix.
Mm.
So it wouldn't be as far off, but again, these are all just proving that we're not in that, perfect world that the wind and current, set and drift all affect it. So we could assume set and drift, but in reality, our running fix gives us a better understanding of where we are than if we just assume set and drift. So that is just letting us know that set and drift is a little bit is affecting us.
Okay.
Okay. Okay. So for assignment 14, we start in Newport. You see Newport here? I didn't adjust my camera yet. Nope. Oh, I zoomed in. Okay, let me get to the edge so you can see my latitude. There we go. Oh. Okay. So, mouse here. we start at the NWP buoy, right there. And we are headed down to Dana Point. Okay, as you prepare your view, the local notice to mariners and see that you're reporting a new lighthouse. So that's just like a correction to the chart. So we are adding in a new lighthouse. Now remember, this is just for training purposes. This is not a real lighthouse. We're naming it fictitious lighthouse. And it gives us a position. So we have 33 degrees, 32.9. I'm gonna get that one in, 32.9. And 48.3. Can you see that? No. 48.3. So right where it says to Rock Point, that is going to be our new lighthouse. So we can even draw in our light symbol. Okay, so we have our new light. You plan to leave the NWP buoy at 0800 and set course for 120 degrees PSC to Dana Point with a speed of 5.2. What is your DR position when you pass a beam of 2 Rock Point? Okay, so they told us our course that we are steering per standard compass. So we need to convert it to true to plot. So we have compass, and that would be adding east minus west. We have a compass course of 120. We go to our deviation table. With a compass heading of 120, we have a deviation. What deviation do you guys see?
Or east.
4 east.
Yep.
And it's east, so we're going to be adding that. We have magnetic of 124. Variation we get from the chart, 12 east. East again, so we're adding. And we get a true of 136 degrees true. So now we can plot that. Find my pencil. So from the NWP buoy, we are going 136 true. So I just have my pencil on the NWP buoy, and I put my focal point on the meridian, and I have 136, and I draw in my line. So this is my course line, and it asked, when am I going to be a beam of 2 Rock Point? So I have my pencil on 2 rock point. I get a 90 to my course and just draw it in. So when is this? Or what is your DR position and what time? So it's both. What is the position and the time? So to get the position, our latitude, we are close to the edge, so I'm just going to use the roll plotter. We are 31, 32.1. The longitude, .2 or 3. And then we need the time. So to do time, we need distance. A distance of 4.1. Distance is 4.1. Speed is 5.2. What is the time? What did you guys get for time?
8:47.
Yep. That would give us 47 minutes. If we left at 8, our ETA would be 8:47. So we have 100 plus 47, 08:47. 8:47. So that was just a practice of getting position, really just plotting positions and plotting our course. Okay, so this one is going to be our regular fix and getting our actual speed over ground. Okay, so at 8, let me erase. So at 8:38, which would be before this, right? This is at 8:37, 8:47. So a little bit before that, we take a fix and we get the NWP to being 313 degrees true. And our two rock point, which is our new light. Oh, that is our new light. So rock point light bears 065 degrees true. So we need to plot in those LOPs for a simultaneous fix at 8:38. So from 8 or NWP, we have 313. And then from our 2 rock point, we have 0.65. Okay, let me zoom in. See it a little better. Okay, so where these two LOPs meet, that is my position at 0838. Now it asked me what was my actual course over ground and what was your actual speed over ground. So our course over ground, because the buoy we left was the buoy we got a bearing of, we already have our course over ground drawn in. We technically already have the bearing of it, but we can get it again. So if I was here and I'm going this direction, my bearing of it would be so my course made good is 133 degrees true. So on that line, this direction is 133, where this direction, our bearing of it was the 313. Now for speed made good, we need to get our distance. Distance of 3.8. So if I have a speed of, what was my speed? Oh, I'm looking for speed, right? And my time was 38 minutes. We have 3.8 and 38. So we have 60 times 3.8 divided by 38 gives us speed. Our speed gives us 6. So our speed over ground is 6 knots, where we thought we were doing 5.2, but we are going a little bit faster. Number 6 says record your position. So we want to get the lat and long so we could record it in the log. The longitude of 49.4, 3 or 4. And then my latitude was, where did I mark it? Right here. 31 to 32.4, 32.5, somewhere around there. And then it said, are you on your original DR line? No. And why? Don't really know why. Possible wind and current would be our answer for that. So any questions on getting a fix and then calculating our speed made good and course made good?
Can you explain the difference again between course made good and speed made good?
Yes. So we have this or this is where we were at 0800, and we have what we think we're doing. So this is what the boat is assuming. We are having a course of, we calculate our course to be 136 and a speed of 5.2. So with that, we got a position, or we have it, we can calculate a DR for here at, what time did we get our fix? Was 8:43. 8:38. And then we got an actual position somewhere around here at 8:38. So this is what we call course made good, speed made good, or course over ground, speed over ground. Those mean the same thing. So what actually happened was where's my little eraser? Here we go. Here's my little boat. We set on this course, but we actually never went on it. Our wake has always followed that pink line, even though our course was set for 136.
Okay.
So then if we connect the triangle, this is our set and drift, which we're going to go into next week. So the line from a past position to a new position is where your your wake went, where you actually traveled from an old position to a new position. Even though your boat was heading something else and the speed was chugging along at something else. Your speed made good and your course made good can be something different.
Okay, thank you.
Hey, Bree, can you show me your course over ground, how you got the heading on that?
Yes, so because on this actual question, my bearing came from the same position, it was the same line. I had a bearing like that or something like what our bearing was. So we measured that line. So if I go back to here, zoom in anymore right here. Okay, so I have this as my bearing line. This was my track line, my DR line. So
Right.
This was my bearing line, and I wanted to know what was my made good. So if I was here at 8 and here at 8:38, I needed to connect those two positions. They're already connected because that's what I took my bearing from. And then I can measure it. And I get 133. So if I'm going this direction, it's 133. Where in the problem, it told me I had that bearing of 313. because I'm down here and it's at 313, north of me. But my course made good, I'm moving to the south, to the southeast.
Right.
So my course made good is 3133. I think I had it like, so this was our 08, 0838. So this direction is 133. This direction is 313. It's the same line.
Okay.
Just okay. Now we plot a running fix.
I've got a question on that. If those are reciprocals, I mean, I would think that they would be like, they would somehow relate to 360, and like 313, it would be
So it's 180 plus or minus.
180. Okay, yeah, okay.
Yeah. So 180 plus 113 gives us,
Okay, I got it. Yeah. I was thinking of a full circle instead of half a circle.
so it's just the reciprocal, yeah. Okay. Okay, so now we do a running fix. The fog rolls in after plotting our 838 fix. You decide to steer further further away from shore, so you change course to 140 PSC, add 5.2. You are still concerned about your position at 856. You get a bearing. At 838, you get another bearing, plot your running fix. Okay. So we need to convert all of these to true. So we are steering, so we're going from our compass. Yeah. So we kind of did this, I don't know, week 2 or 3. So we had a heading. And then we're gonna have the hospital. And then we're gonna have 2 rock light. Okay, so our compass, we are heading at 140. Our hospital is bearing 103. And our 2 rock light, no, our 2 rock light we already have as true. Oh, we're using our other LOP, that's it. So 065, okay. So we need to convert these two to true. With a heading compass of 140, our deviation is, what is your deviation?
East.
To east. If it's east, we're going to be adding. So we have 105 and 142. Variation is on the chart at 12 east. We're going to be adding that again.
Hey, Bree,
Yes?
the deviation on the hospital isn't 2 east, it's 5 east.
So remember, it goes from your heading,
Oh, that's right.
not the bearing. Yep. Okay, so 42, that's, nope, can't do math in my head. 5, 154, and 17, 117. Okay, so that up here so then you could see me plot. I've lost my pencil. Okay. We are plotting South Laguna Light bearing 117. So we find South Laguna Hospital, which is right here. And it is bearing 117. I can't do that. Okay. Okay, so I have 117 on the focal point and on South Laguna Hospital. So I can draw in my LOP. I'm somewhere along that line. And for my 2 rock point, I had changed course to 140 from this position. So let me get 140, no, 154, excuse me. Okay, so I have my LOP at 838, and I need to advance it to this LOP at 856. See how far we advance it. We have 18 minutes. We are going at a speed of 5.2. We're looking for distance, and our time is 18. So what is our distance? We have okay, so I got 1.56 nautical miles. 1.56. So from my line where it crosses my my DR line, which it starts at, I can swing an arc. So I just tick that line, and then I need to parallel this line. I gonna do it looking parallel, easier to see. So I parallel this. And this line is now my 838 to 856. And this is my 856 line. So where those two 856 lines meet, that is where I'll be at 856. So something is really pushing me closer to shore. The current and the wind are coming up. All right, how'd you guys do on this running fix?
A little complicated, but
Yes.
we just gotta
yes.
work. We gotta work problems, I think.
Yep. Work it a couple times. We'll have another practice on our final one.
Bree, I think that the time interval between the taking two, two fixed, right, or two measurements has to be really small to keep that accuracy, right? If you the time interval between the two is too long, then accuracy will be sacrificed or compromised. Is that the correct statement?
Yes, because the further you get away from your known position, the more things are going to affect you. The more set and drift will affect you. The more steering error will affect you. The more, things can happen. So the further you get away from your known position, the further out your kind of window of where you think you are. It gets more blurry.
Yeah, the closer you are to being lost.
Yeah. Okay. So this gets a little more confusing. Okay. Well, let's do it. We finished that. Okay, so we have at 8:56. From your 8:56 running fix, you drift for a while, deciding what to do, and decide to change course to 160 PST. At 9:28, you decide to head further offshore. Okay, so that's the same thing, and steady on 160 PSC. I'm just gonna delete that. You decide to take a bow and beam bearing fix. You see the building in Dana Point bearing 315 relative, and you are motoring on a course of 160 PSC at 5.2 true. At 10 o'clock, you see a beam. You are careful to hold your course and your speed. You are confident you can get a good fix. What is your bow and beam fix? Okay. So we have changed course to 160 PSC. So we need to change that to true. And then we had we saw it on our bow at, why can't I see the time here? Oh, 09:28. And then we saw it on the beam at 10. What is our bow and beam fix? Okay, so we need to convert this guy to true. So I'm gonna go from compass at 160 PSC to true. So I use my deviation table.
0.
To 160, 0. Yeah, I think I said that. So we have 0, 160, and then our magnetic was 12 east.
12 east, yeah.
East is we're going to add, so we have a true of 172 degrees true. Okay, so we can plot our 172 degrees true. One 172.
Hey, Bree, what do you, oh, okay, I see.
What was it?
How'd you do that triangle fix again?
Okay, yeah. So I had, because it's close to vertical, it's harder to reach. So I just put it on the white so it's easier to read. Focal point on the line, and then 172 on the line on a meridian.
Okay.
And then you use the short side of the triangle, put something straight, ruler, whatever, and then you can parallel it to the line in question.
Okay, so you line it up, you made a 172, put your ruler there, and then it allowed you to move down to your fix off of 2 Rock Point.
To your 856 fix.
856 fix. Yeah, that's off the 2 Rock Point, right? Oh no. That
It was
is,
from the hospital and then running fix from 2 Rock Point.
oh, I see what you're doing. Okay.
Okay, so
So 172.
so we have our course, and we were using the building in Dana Point. So that's this guy. And I'm gonna get a beam bearing. So my beam bearing would say I'm somewhere along that line. But I know I drifted for a while, so I don't know exactly where I am. We have to find out the distance run is equal to distance off. So our distance run between 928 and 10. So we have 10 and 928. That gives us 32 minutes. Plug that into our 60 D Street. We have a speed of 5.2. Distance is what we're looking for, and time is 32. What do you guys get for distance?
$2.7.
2.7. We got 2.8.
2.8. 2.77.
I'm gonna call it 2.8, 2.77. So I'm somewhere along this line. Now I have a distance off of 2.8. 2.8. From my building. I have a bow and beam position right there at 10 o'clock.
You just took your compass and measured 2.8 out from your,
Correct.
okay.
Hey, Bree, can you show me how you got that building line?
Yes. So I used my triangle. What tool are you using?
Triangle.
Okay. So I put the course line on the 90-degree line.
Okay,
And then I put my pencil on the building
okay.
and I drew the line.
That's it, huh?
And a beam is always going to be 90.
Yep.
Okay.
Simple enough.
That was easy.
Nothing's ever simple, right?
Okay.
Okay. And then it asked us what was our position, so we can get the lat and long. And then on the fathom curves, what are we between? So remember our fathom curves, and we have the numbers up here.
200 and 250?
Yep, 200 and 250.
Hey,
Alright.
Bree, why was the 315 degrees mentioned for the building?
Okay, so the 315 is relative. So that means it's a bow bearing. So we are cruising down here at, what were we doing? 1-1. We're doing 117? No, sorry, we're doing 172. Okay. I was looking at the wrong question. Okay, so we're cruising this way at 172, right? Now, when we do relative, we always start from our heading and we go clockwise.
Okay.
So that is our 315 to the building. which is also, you know, our 45 to port instead of starboard.
Oh, okay.
So
Oh,
it asked us,
okay.
it actually asked us, number 10, what was the true bearing of, what was the true bearing here? So if due north is 0 and my heading is 172 plus my 315 gives me a really large number, or I could subtract my 45 from my 172. Either way, we want to know what the true bearing is. So that would be from true north to the line in question, what is that angle? So we kind of have a little puzzle on our hand, right?
Yeah.
What's the missing number? So we can do two things. If we go with my R plus S equals T, we get our relative, which was 315, plus our ship's heading, which is 172, equals a really large number, 487. So that means we went from north all the way around plus another bit around. So in order to get that, we have to minus 360. And then we get
127.
127. Or we could have gone 172 minus 45. And that also gives us 127.
So you did 315 as your relative, and then you did plus 172. Is that your S?
Is that your what?
You got 315 plus 172.
Yes.
So that's relative plus true?
Relative plus ship's heading equals the true bearing.
Oh, ship heading. Okay. Is 127.
Okay, so our next little section, last section here. Weather is still a factor, so we decide to just come into Dana Point, which was our plan all along, but we want to stay for the night. So we come left to 100 PSC, and at 10:25, we see the building and this buoy in line. And then we also see the cross. So we're getting a position at 10:25. So we need to calculate our position or change our information there into true, so we can plot it. So we have our heading and our cross. We started with C. Oops. So our heading, we changed to 100. and our cross was bearing 038. So our heading was 100, so we go to the deviation table.
Five east.
5 east. Yep. 5 east. It's east, so we're going to add. We have 105 and 43. And then our variation is 12 east. So that is 117 and 550 and 055 degrees true. So that's what we're using. Our truths. So we have our 2 lines of position here. One, we didn't get an actual number. We just got a visual range. So how do we plot that? Is we just, let me try to zoom in on this again. See that? Better? Okay. So, triangle here. We first see the visual range of the building and the buoy in line. So all we have to do is connect those two. And we know we are somewhere along that line. And then the other piece of information was the cross here was bearing 055 true. Page here. So hold on real quick. Okay. Cross and 5, 5.
What are you setting the bullseye on your triangle on?
So I extended my my lineup.
You can do that, huh?
Okay.
Yeah. You can do it from this one and then move it over. I guess I'm taking a shortcut. So I have a 1025 and I am headed 111.
Hey, Bree, can you show me how you got that cross line again?
Yes. So Did you extend this meridian?
Yes.
Okay. So I put my pencil on the cross,
Okay.
and then I aim for my focal point to be on the meridian,
Okay.
and then I move it around until I get 0, 5, 5. So pencil still on the cross. Looking for 5, 5 and focal point. So I got the focal point up here, 0, 5, 5, and my pencil on the cross.
Oh, okay. 0, 5, 5. Okay. I see what you did.
So I'm right next to that buoy.
Yeah.
Headed into Dana Point. Okay, so it asked us what our position was. And then it said, how far did you cruise between these two fixes? So that's going to be your 10 o'clock and your 10:25. So if we go over ground, we could connect those two lines. It didn't ask us for a course over ground, but I connected the lines anyways. We get our distance between these 2 points. Almost 3. We'll call that 2.9. Distance is 2.9. I'm looking for what my speed over ground was. So what was my time? This was 10, and this was 10:25. So I have 25 minutes. On the chart there. Oh, let's do magic stuff.
Seven,
What speed did you get?
7 knots.
7 knots.
6.
7 knots. So we just get more and more practice with our plotting, right?
So, hey, Bree, so the story is at 10 o'clock, the skipper changed heading to 100 degrees
Correct.
PCS, and then at 10:25, the skipper saw that the buoy in the building was lined up.
Correct.
And he could also see the cross.
Correct.
And so that gave him a fix
Correct.
just off the buoy.
Yep.
By about half a mile, less than that.
Yeah. Like 3/10 of a mile.
Yeah.
Amazing.
Now, a lot of times in our recreational boating world, if we pass very close to a buoy, we can just call that buoy our position. And
You say close, like within a half mile, or?
I would say maybe 2/10. I like to say 2/10 is my rule of wiggle room. Try to get your fixes within 2/10 of the answer, kind of thing.
Okay.
Yeah, that's a little over 1,000 feet. You should be able to see that.
Yeah. And of course, if you are,
3 or 4 football fields.
you know, navigating in close waters, maybe you're gonna bring that back down to less than 1/10. But
Yeah, if you got swells, right?
yeah, it's all dependent. And if you look up, oops, uh-oh, sorry. Let's see if I can switch this around. Yeah, okay. You look up at the top of the chart. Put it around my house here. This is the the chartlet for Dana Point. So we could, we don't have the building on here, so we couldn't have plotted that range. But I just wanted to point out on here, we aren't in tenths of a mile. We're in minutes. You guys see that?
Mm-hmm.
Yeah.
So on the big chart, our latitudes look like this, and we're in tenths of a mile. Here, we have, what is that mile? Is a mile? That doesn't make sense. This is a half mile. Oh, yeah. So this is 57, and then seconds, 10 seconds, 20 seconds, 30 seconds, 40 seconds, 50 seconds, 60. So this right here is a mile. Anyways, I just want to point that out. Okay. What else do we got here?
Hey, Bree. Quick question.
Yeah.
Why, for the deviation for both the cross and the building and the buoy, why did we use 5 east for both the 100 degrees and the 38 degrees?
So our heading is what we go into the deviation table with.
Got it.
Not the bearing.
Okay.
So we always go in with our heading. So our deviation is based on our boat and where our boat is pointing. If we didn't change our boat, we kept our boat pointing the same way, we just got a bearing.
Okay.
So there's that difference between heading and bearing. Let's see. Let me get my paper out of here again. I was gonna ask Janice, are you with us?
Taking a nap, I think.
Janice?
Well,
Yeah, I'm here.
Okay. Did you want to talk a little bit about plotting for sailing for me
Sure.
versus
I can
powerboat
do
for
that.
sailing?
Um,
Might draw a picture of it.
yeah, I'm sorry I didn't respond. Sometimes my audio is not real good. If you're plotting a course for sailing, it's not really too different from when you're plotting courses for power. Where you get into issues that get kind of more complicated is if you have to go upwind and the course that you want to sail is directly where the wind is coming from. So if the wind is coming from due north and you want to sail due north, you can't sail that direction. And that's what they describe as the no, I think they call it no-go zone. And that's kind of new terminology. For me, it was just, you can't point that high. So, but that no-go zone is usually about, if you've got a really well tuned up boat with good sails and a nice hull design, you might be able to sail as much as 45 degrees from the center of the wind in on either tack, starboard tack when the wind is coming over the starboard rail, or port tack when the wind is coming over port rail. In less tuned up boats that are more typically used for like weekend bopping around and cruising, that ability to point up into the highest point that you can sail would be about 60 degrees off of the center of the wind. And I've even sailed on boats where we were happy to get 70. So, I mean, we were doing a close reach and we were real happy about it. So what you're going to end up doing is to go in the direction that you want to travel against the wind. You have to sail a zigzag course. And what you'll do is try and stay as close to your intended course as possible. But you're going to have to sail away from it. And just as Bree's demonstrating, you're going to be zigzagging to go upwind. If you're in the smooth waters, probably either tack would be about the same. But when you get out in the ocean and you're dealing with waves and swells, sometimes you'll find that you're just cutting across the swell on a better angle on one tack than the other. And so you might find that you make actually better speed on the tack where you're getting a better ride over the swells. So what you may want to do is stay on that better tack, and it may be more comfortable. You know, if you're going to be doing it all day, you want to be comfortable so that you don't get too tired and all that. But what you may want to do is do a long run on one tack, do a short run on the other tack to kind of bring you back to your intended course line, and then go back over on that more comfortable tack. The reason I suggest that you don't stray too far from your intended course line is because the wind will change direction. And sometimes you get a really significant wind shift, and it might be in your favor. So if you've gone way away from your course line, your intended course, you may have to sail a lot of extra miles to get back to where you could have been if you'd stayed closer to your intended track. So if you happen to get that really favorable wind shift and you happen to be near your intended course, it just, you know, it's nicer, it's faster, and you get there sooner. Let's see what else. You have to keep track of these tacks. So every time you tack, you need to plot a new DR course. And it's a really good idea to plot out or hour so that you have an idea of where you're going to be at these intervals. That can help you decide whether or not you'd like to tack. So if you were traveling on the orange course that Bree is plotting, the dead reckoning shows you good points at which you might want to plan a tack. And then same for the green as well. The other thing that will happen, especially in the waters around here, in the mornings, the wind tends to be very light. This is more like summertime conditions, but the wind tends to be very light, almost non-existent. And then it builds throughout the day. And in the afternoons, you have a pretty strong breeze. as that wind builds, to west southwest, or usually doesn't go too much past southwest. But I worked at Catalina, and sometimes in the mornings I would have a wind that was out of the west. I'm sorry, out of the east, and then at noon the wind would totally lay down and die, and then I would get a west wind in the afternoon. But I was working very close. I was doing a tour along the east end of the island, so I was within a couple miles of the shore. I was in a power boat, but I noticed the wind. So you can get pretty radical wind shifts. Also, if we've been in Santa Ana conditions and those are starting to break down and go back to our normal sea breeze, what can happen is you can end up with winds, offshore winds, and then you may have a period where there's very little wind, and then the sea breeze fills in from almost a completely opposite direction. So, so that's another thing that would cause you to have totally different wind conditions over the course of the day. But usually you don't get that much variation. And you would, if you were sailing and there was any chance of Santa Ana conditions, you would know that because you checked your weather forecast before you headed out. That's something to pay careful attention to. Let's see. If you are sailing dead downwind, say the wind is coming from, instead of north, it's coming from the south, and you want to go north, so you've got the wind completely straight behind you. Sometimes, depending on the sail plan that you have for your boat, that can be a little bit of a rolly situation. And especially if you don't have the right sails for it. And so sometimes what people find is it's actually better to sail a little bit more of a broad reach than dead downwind. So basically what you do is you sort of tack downwind, and so you would be doing a zigzag course to follow your intended course line. So you might sail with the wind coming, a few degrees over your starboard quarter, and then you would either tack or controlled jibe, and have the wind coming over your port quarter. And what that does is sometimes it just gives you a little bit better angle on the swell, and you might get a little bit more speed out of it. You're traveling more distance, but you might have less rolling, and it's just a little bit more comfortable. And if you're going to be doing it for several hours, it's something to consider. Any questions? Does this stuff make sense?
Yeah, makes sense.
Yeah, that was great, Janice. Thank you
Yeah.
very much.
Oh, you're welcome.
Yeah, Janice,
I
I have a kind of expanded question. I never used the autopilot. I assume the autopilot for sailboat can only work as long as you don't need a tack, right? As you remain at one tack, you can rely on the autopilot.
It really depends on the autopilot and how it determines the error. There's different methods of like when the boat gets pushed off course, and how the autopilot determines how much you got pushed off course, how much to correct to get you back on course. If you've got a good system that doesn't overcorrect, then you can use autopilot when you're sailing. And there's a brand that we used. It was called Benmar, but they're not out there anymore. But we used it sailing quite a bit. But I have seen autopilots that if they went too far off course, if say there was a wind gust or a big swell kind of pushed the boat around, the autopilot would go too far to bring the boat back on course. And then that caused if you were sailing close hauled with your sails in tight, sometimes that would cause the boat to go into the no sail zone or the no go zone. And then the boat stalls, and then you can
Hello, Janice?
have a good autopilot. It can be done. You do absolutely have to have somebody standing watch, and it's not, for other vessels, but also just to make sure that if the autopilot is set to follow a certain course and your wind changes, you may be able to take advantage of that slight wind change, but you've got to be there to notice it and take action on it. If you're using a wind vane, which is a way of using the point of reference for the wind vane is the wind itself, and it steers the boat at a particular angle to whatever the wind is. If the wind changes, the wind vane will allow your boat to stay at the same angle to that wind, but it may put you off your compass course. So either one of them, you really have to monitor and make sure that that you adjust as needed.
So the autopilots only control the rudder, right? Not control the sails.
That is correct. Yeah. The autopilots are usually set up to work through the rudder system, and a lot of them have their own compass. So you dial in a compass course, and then the autopilot will steer to that course.
All right. Well, thank you, Janice.
I'm hearing a lot of noise. Was there a question out there?
Oh, I just said thank you. That was information.
Oh, okay. I'm sorry. Yeah, my internet connection is not very good, as you know, and so sometimes I don't hear anything at all, and this time I didn't. I just heard some funny noises.
That's great.
Yeah, it's the other thing that is good to know, and it's the
Uh-oh, now she's breaking up.
them power boats, they sometimes really feel the effect of a current setting against them. So, or if you happen to get into something like the Gulf Stream, it's like you put turbochargers on the boat if you're going in the same direction as the Gulf Stream. So knowing how to cope with that is always good.
Currents and wind. Speaking of currents, next week we are going to go into a little bit of the set and drift practice. So the homework for this class we did in class, right? All of assignment number 14. The next assignment is the final assignment, which I recorded a tutorial today, so I'll have that posted in the next day or so. And I'm not gonna go over that in person, unless you have some specific questions. I can do that next week. But next week I'm gonna focus on some set and drift exercises. So a little bit off the curriculum there, but I'll send you a PowerPoint on Sunday and some extra practice problems. And that's what we have planned for our last class.
Great.
Yes? All right. Well, let me know if you guys have questions along the way, and I'd be happy to help. But that's all we got for tonight.
Okay.
Okay.
Thanks, Bree.
Thank you.
Good
It
night,
was
everybody.
good.
Thank you.
Thanks, Bruce.
Good night. Oh, I have to